Now tell me, in a distributed setup, okay, when you
Hmm.
need to have a communication between two queue managers from queue manager A to queue manager B, how many
Hmm.
definitions you need? How many channels you need at the source side? How many channels you need at the destination side?
So source side one and destination side one.
So this is one way.
Yeah.
So two-way means,
So two means we need four.
so we need a, okay, we need four channels
Yeah.
between two queue managers, correct?
Yes.
Imagine if I have around 10 plus queue managers, 10 queue managers, okay?
Hmm.
How many channels you need? Communication between 10 queue managers.
Okay. Between 10 queue managers. So we need 20.
So 10 into 2, 20. 20 definitions you need, correct?
Yeah.
So this is, you might be imagining from queue manager A to queue manager B, something like that.
Okay.
For example, if I need to have again queue manager A to queue manager C,
Hmm.
again the same queue manager A needs to connect to queue manager D, then
Yeah. Then
so
we
from
may
queue
need
manager A to other queue manager, if I
hmm.
have a 10 queue managers,
Yeah.
0, 1, 0, 2, then how many? 1 to, if I have 9 channels, 9 queue managers, 9 into 2, 18 definitions here required.
Hmm. Yeah.
Correct? Here also 18
Yes.
required.
Hmm.
Here also 18 required. Okay, here A, B, and you can say C, 18 required.
Hmm.
Now you are getting my point, what I want to say.
Yeah. Yeah. Yes.
So when you have a multiple queue managers under an umbrella, when you need to
Hmm.
have A to B and A to C, A to D and all, for each and every queue managers communication, two sender channels, two receiver channels. One sender, one receiver is required at source side, one sender, one receiver is required at destination side, correct? So if I say this same requirement, I can achieve through MQ in a very short form through clusters. When I have 10 queue managers, I need only two channels for queue manager. For 10 queue managers, how many? 20. That's all.
Yeah.
This is what the benefit of cluster. How this
Hmm.
functionality is going to work, I'll explain. Okay.
Okay.
So
Okay.
in the distribution setup, we have seen remote queue, transmission queue, and then you will have the communication. But here in
Okay.
cluster concept, there is a no need
Hmm.
of remote queue.
Okay. Okay.
You got my point? There is a no
Yeah.
remote queue concept at all.
Hmm.
It's just that when you define a local queue, okay, queue
Okay.
local LQ, you have to give cluster of cluster name. That's it.
Hmm. Okay.
So this queue is available at cluster level. If this queue
Okay.
is part of cluster, for example, 10 queue managers are part of this cluster. Okay. Then this queue
Okay.
is visible in all the queue managers.
Hmm.
So it can accessible anywhere.
Okay.
That's the beauty of cluster. So now you need to know some basic setups here, cluster. Okay. What is that? as per the IBM recommendation, there is some concept called full repository. So repository in the sense which maintains a cluster information. Okay. You cannot have all the queue managers as a full repository. IBM recommended 2 queue managers as a full repository because if something goes wrong with A, then B can handle the cluster.
Okay.
Now rest of the queue managers are considered as a partial repository queue managers. Partial repository queue manager means they have their own queue manager information and they have the information of a queue manager which is sending or receiving information from them. That's all. But
Okay.
whereas
Okay.
full repository going to have the information of all the queue managers in the cluster.
Okay.
So you can say they are the boss. Now these are the employees. They just need to perform their action. But these guys managing everything end to end. In which queue manager, what is the information is there? Which queue manager who is sending a request to whom? Okay. Am I clear on the part? Now, how we define the channels, we'll see in the syntax. Now you understand why we are going for cluster. Whereas if you go with a distributed setup, you need a huge number of definitions. To avoid those things, we are going to full repository and partial repository channels, which is at cluster level. Okay. Now, first is create a queue manager. You are going to create a queue manager. Okay, we know how to create a queue manager. Decide which queue manager you want as a full repository. So for example, I have a 0, 1, 0, 2, 2 till 10. Okay.
Okay.
So how should I decide which queue manager? You can take any random queue manager and you can make an alteration of queue manager attribute called repose. Okay. There is some attribute in the queue manager. When you say display QMGR, SSL key, or you have seen, right, attribute. Like the way display QMGR repose. By default, it is a blank.
Okay.
Now, when I give say as a alpha, then this alpha is the name of a cluster then.
Name of the cluster.
Yes.
Okay.
Whatever the name you are going to give here, that's going to act as a name of cluster, or you decide what cluster name you want and put that name here. But whatever the name you are going to give it here, that will be acting as a name of the cluster. So what is the first step? Out of 10 queue managers, which queue managers you want to decide as a full repository? This is our first job. Okay.
Okay.
Am I clear? So first you are defining the bus. Now the next is go ahead and create cluster sender, cluster receiver channels in all the queue managers.
Okay.
So you have a 10, correct?
Yeah.
I have queue manager A. I have queue manager B. Imagine these two are full repository. So what I have to do? Alter QMGR repose.
Suppose. Okay.
Name, cluster name.
Yeah. Yeah.
You can give anything.
Okay.
The same thing I'll give it here. Full repository. First, we need to understand this concept so that we can do the lab. Okay, it's not like other concepts. So little bit complicated when you don't understand in the beginning.
Okay.
Now, what are the steps that I'm going to perform in this other queue managers? I don't need to perform anything, because if you don't do anything, this repos is blank here. Partial repository repo is blank. So no need to do anything.
Okay.
Now, what is the next step? You need to have bidirectional communication between full repository queue managers.
Okay. Okay.
Why? Because, hey boss, I am the boss and you are the boss. If something goes wrong with you, I will take care of traffic.
Okay. I
If
have a
something,
question.
yeah,
Here, then we can have the full repository queue manager on two different machines.
yes, you can.
Okay.
That doesn't matter at all.
Okay. Okay.
Because you are going to give the IP address in the con name.
Okay. Okay.
Okay, it can be any operating machine. Yeah, that's not a problem.
Okay.
But whereas all the partial repository queue managers will point to only one bus.
Okay.
How I can, okay, imagine this arrow is also pointing to here.
Okay.
Hmm. You got this arrow, right?
Yeah.
Now, no one is pointing to this queue manager. Everyone is pointing here only. Okay. But what all the information is here in this queue manager? Okay.
Okay.
Imagine this is a QMGR01.
Okay.
That particular everything information will be there in QMGR02 as well.
Okay.
Whatever here is there, whatever here is there. But
Okay.
with respect to partial reports, okay, they have their own information only. They don't have any information related to this. For example, this partial repository queue manager has to connect to this queue manager. Okay.
Okay.
Now let me name the here queue manager 03. Queue manager 04. QMGR 05. QMGR 06. Okay. Now imagine if 3 has to communicate with 4, then will they directly communicate each other? No. Queue manager 3 will go and tell to queue manager 1, hey, I have to connect to queue manager 4.
Okay.
Can you please help me?
Okay.
Then it will say, hey, don't worry, this queue manager 4 is also part of my cluster. You can create one fly channel. Fly channel means a temporary channel will be created between 3 and 4 for time being.
Okay.
Once the request is sent or received, it's gone. For example, if queue manager 4 has to connect to queue manager 6, queue manager 4 directly go to this full repository. hey, I have a requirement of connecting to 6. Can I? Then it will check repose name cluster. Okay, is this queue manager is part of this cluster or not? Yes, it is cluster. Okay, then you go ahead and create a fly channel. So few of the channels are called as a fly channels that will be created by cluster itself based on the request. You no need of remote queue and all. Everything is done by automatically. None of the partial repository queue managers will connect each other directly without notification to queue manager 01. How this happen? That's the beauty of cluster.
Okay.
They will make sure first go to full repository queue manager, they'll check part of a cluster or not, then they'll create a fly channels. So now, when coming to definitions point of view, I need one cluster sender channel which is pointing from Q03 to Q01, right?
Yeah.
So what is my class SDR? What should be the name? Queue manager 03 dot queue manager 01, correct?
Hmm. Correct.
I'll copy this, I'll come here, I'll paste it here. Now tell me, okay, I'll copy here.
Your
Now,
queue manager
this is
04.
4, correct? Zero 5.
So the partial queue managers will have connection to queue manager 2 also, right?
I'll come to the point. Okay.
Okay. Okay.
So my partial repository queue manager is having connection to queue manager 1, correct? This
Yeah.
4 is having connection to this one.
Okay.
5 is having connection to queue manager 1.
Okay.
6 is having to connection. Whatever the communication is there, right?
Mhm.
Whatever the
Yeah.
channels has been created. Now this channel you see from QMGR01 dot QMGR02. Now this is a cluster sender channel. Now this cluster sender channel will tell, hey boss, I got all these partial repositories. These many channels are going to this information will be passed through this channel to this. It won't connected with the partial repositories. It will connect only with the full repository. Because
Okay.
if something goes wrong here, then all these connections you see, right, they'll point to here.
Yeah. Okay. Okay.
Like
Okay.
this.
So that will happen automatically.
Exactly. Automatically. You don't need
Okay.
to do anything here.
Okay.
Because you are already defining the cluster sender
Mhm.
channel from
Yeah.
QMR
Yeah.
01 to 02.
Mhm. Okay.
If it is failed, then only.
Mhm. Okay.
I hope now the everything is clear.
Yeah. Now one question. See, some application want to connect. Okay.
Mm-hmm.
Now we for scenario like we are having the full repository queue manager on, queue manager 01 on machine A, queue
Okay.
manager 2 on machine B.
Uh-huh.
Now application will have its IP, the machine A IP or machine B IP.
Why they need to have a IP?
No, they want to connect
They want to connect to
listener
the queue
port,
manager or queue. They will connect to the
listener port.
port. That's all.
Yeah.
IP will not be a dependency here.
No, but the application want to connect that particular port, then they will have to use the IP also, right?
Yes, call name, IP address they have to give.
Yeah. It, which IP they will use? Queue manager 1 IP or queue manager 2 IP?
See, when you use AMK put, did you use IP address?
No, actually, AMQ Sport, we are doing it from the local machine. Local means QMGR01 machine.
Okay.
Just I want to do it from the remote box.
Mm-hmm. Mm,
Then
yeah, your question good. In that
okay,
case,
for example,
then
for example,
then
uh-huh.
in that case, if that is the case, then you have to go with a load balancer, I believe. I'm not
Okay,
sure,
okay.
but yeah, there's something will come as a okay. Let's put this in a normally definitions point of view, clusters point of view. That is the concept. Okay, so let's put this
Okay.
question in the chat.
You remember in VAS when we do the JMS configuration, we used to give the MQ, yeah, MQ host name IP also, MQ host IP also.
Yes, yes. When you have queue managers on different machines, part of same cluster, how do you put messages? Correct?
Yeah, from the remote box. Okay.
Yeah, that is fine.
Yeah.
See, order. Here, there is no question of IP at all. Simply open to put order queue. You just give a queue name and queue manager name. That's all. Cluster channels, cluster sender and cluster receiver channels to connect to the queue manager. Full repository, blah, blah, blah. In clusters, you don't define a remote queue. Okay. If multiple queue manager host the same cluster queue, MQ load balancer will using a round robin. This is a okay. This is different. This is after reaching connectivity. Full repository, partial repository. Okay. Application put messages by using. But see here by queue name only. You're getting point.
Yeah.
So there is no question of IP here.
No, actually, no. In VAS side, normally we used to open firewall request for
Hmm.
request. Okay, to open the port between VAS and MQ.
Okay, VAS and MQ. Okay.
So that time we used to give the MQ IP.
You are saying if my two queue managers are in different machine, how it will go?
Yeah, yeah.
Okay. Then you have to check that configuration how it is really configured because in cluster point of view, we'll just communicate with the queue and queue manager. That's all.
Okay, okay,
Okay.
okay, okay, okay. I'll check.
You just explore it how it is. Okay.
Sure, 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 sure.
I'm also interested to know about it.
Okay.
So as of now, this is what the setup is. I mean, internally,
Hmm.
when you do the
Hmm.
setup, this is what the
Okay,
definitions are.
okay.
Now, each partial repository queue managers has a cluster sender channel, correct?
Yeah,
How about receiver channels? Plus RCBR, okay?
yep.
Now this
Okay.
class RCBR, which
Hmm.
means the request is pointing to itself.
Okay.
What should be the name? The request is coming to queue 3, right?
Yeah.
Now it will say 2.umgr03.
Okay.
2 dot qmgr 04. Two dot qmgr 05. So clear?
Yeah.
All the naming conventions of our respective cluster receiver channels is this. So now these many things we have to follow. So what we have to do, I'll frame some comments here. Okay.
Okay.
In your machine, what is the name of the QMS you have? A01, is it?
A01, yes.
A01, B01 you have.
Yeah.
Okay. So we'll take some new setup. Okay. 01
Okay.
you have? Only 01 you have? No.
01, no.
Okay. So first you have to create CRT MKM QMGR 01. Okay.
Okay.
CRT MKM QMGR 02. CRT MKM QMGR 03. CRT MKM QMGR 04. CRT MKM QMGR 05. Okay. 5 will be enough. First 2 will decide as a full repository.
Okay.
Full repository in the sense, what I will do, I'll start the queue manager and then strmkm. You start the queue manager and then
Okay.
alter the QMGR repos. What would be the cluster name you want to put?
Okay. Okay.
I'll give your name only. Okay. Now
Okay.
this is the cluster.
Okay.
Now this is again the same.
Same.
As part of
Okay.
a partial repository,
Okay.
no action here.
Okay. Oh, okay.
So once I give this commands to you, that will be damn easy for you. Okay.
Mhm. Yeah.
Now each queue manager has to listen on one particular port, right? Mandatory.
Correct.
Each
Correct.
queue manager needs to have a port. So let's see how I have defined the listener naming convention. LSN dot queue manager B, LSN dot queue manager B, LSN dot queue manager C. Why? Because you need
Okay.
to, or else if you give some other names, you will get confused.
Mhm. Okay.
You should need to know either belongs to which queue manager. Listener belongs to which queue manager. See, for queue manager A, I have taken 1419. Okay, this is the
Yeah.
listener port.
Okay.
So this is the definition. So let me come down. What is the port here? 141419. So
Okay.
then here 1420.
Okay.
1421.
Okay.
1422. 1423. And what is the syntax to define the listener? This is the one.
Mhm.
So 01.
Okay, I have one question. Actually, while configuring the SSL, we exchange the certificate, right? But here, if we do the SSL for cluster, then we need to exchange between all the queue managers.
SSL, that's a good question. Here, I have seen SSL only for distributed only.
Okay, okay. Okay, I'll check.
1, 2, 3, 4, 5. So 02, 03, sorry, 03, 04, 05. Okay. One four one nine, 1420. Looks like they want more people, then only they'll start a batch, it seems.
Maybe, yeah.
Define listener name. Okay. So 1419, 1420, 21, 22, and 23. Okay. So listener is done. So queue manager up and running. So you have created a listeners. You should not start the listener. Okay. Listener starting activity should be at the end after the definitions or everything is done. So as per our diagram, queue manager 1 will be pointing to whom? Queue manager 02, correct?
Yeah.
So I need a center channel in queue manager 01, which is pointing to queue manager 02. So I'll just try to copy one definition here. So 02 we have to queue because 2.02. Okay, this request is going to queue 0 from. Okay, this is a cluster name localhost. This queue manager 02, what is a port? 1420, correct?
Yes.
Now, queue manager 01 needs to have its own listening request, correct?
Yeah.
Receiver channel has to point to itself.
Okay.
What is the port of queue manager 01? 1419. So when it is coming to receiver channel, okay,
Okay.
you have to give the wherever it is pointing. Queue manager 01 means what is the port of queue manager 1419.
Okay.
Whereas in center channel where it is pointing, queue manager 02. What is the port of queue manager 02? 1420.
1420. Okay.
So this is how we have defined.
Okay.
Now in the same way, this QA02 is also full repository, right? Again, this is to have a communication to QA01.
Okay.
This is a bidirectional
Okay.
because both 1 and 2 are full repository, right?
Yeah.
So I'll copy these same definitions. I'll come here. So what is the cluster channel? Center channel request is going to QM01. So I'll change here 01. What is the port of 01? 1419, correct?
Yeah.
So pointing to queue manager 02. Okay. Cluster receiver channel. What is the port of 02? 1420. 1420. So is this clear now? Queue manager 01 to 02. These are the definitions you have to create in QMGR01, and these are the definitions which you have to create in QManager 02.
Okay. So go to that Pinterest.
Go to
Just
what?
open the MS Paint.
Okay.
Yeah. Okay. Okay. Queue Manager 1 and 2. Okay. We are now configuring only full
Full
repository.
repositories.
Full
Only
repository
1
queue
to
managers.
2, 1 to 2, 2
Okay.
to 1.
Okay. Yes. Clear. Okay.
So 1 to 2 communication. This one. This is 2 to 1.
Okay.
So now the full repositories bidirectionals is over.
Mm-hmm.
This is full repository, and this port is 1419. This is full repository 1420. Okay. Now QMGR 03. Okay.
Okay.
Now where the QMGR 03 has to point to QMGR
QMGR 1.
01. Correct?
Yeah.
So let's write QMGR 03. Is it a partial repository or full repository? Partial repository. What is the port of this? 1421.
21 we can give. Oh, okay. 1421. Okay.
1421.
Mhm.
Okay. Now below this, so my QMGR 03 has to point to QMGR 01. Correct?
Yeah.
So 2.QMGR, same central channel will work for me here. Because I'm pointing to QMGR 01, which is a cluster central channel, which is a pointing to QMGR 01 port is 1419. Correct?
Correct.
So this definition I'm using at where QMGR 03.
Yeah.
Now coming to my receiver channel. Receiver channel QMGR 03. Correct?
Yes.
What is the port? It has to point 21.
21.
So QMGR 03 to 01 is done. Correct?
Oh, yeah.
So here there is no bidirectional here.
Okay. 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 Stay.
In above we have seen bidirectional. That's why we have created here.
Yeah. Okay.
But here there is no bidirectional, only one direction.
Okay.
1 to 2, 2 to 1 because they both are full repositories.
Okay.
But this is partial repository. That's the reason there is only one way. That's all.
Okay.
Now I'll copy this entire setup. Now what is the queue manager? 04, correct?
4. Yeah.
04 again also have to point to where? 01 only.
1. Yes.
So this definition works. 01 cluster sender TCP localhost 1419. Yes, it works. Now where it is pointing to? 04. What is the 4 port number? 20.
22.
It works. Cluster receiver channel. Okay. Localhost 1422. This one. What is the next? 3, 4 we have done. 5,
Okay.
6. In all the partial repository queue managers, sender channel, no need to change because all are pointing to same QMGR 01. That's the reason no changes in here.
Okay.
This is 05. This is what? What's the number? Port 1423. Clear?
Yeah.
0 is pointing to 01. So no change in a 2.qmgr01 cluster sender. Define channel Q05 cluster receiver. Now next is what? Queue manager 06. Queue manager 06 is pointing to 01. Queue manager 06. 222324. 24 only, right? We have discussed.
Yeah.
Okay, we decided till 5 only. Okay. That's enough then. You want to go with 6 also?
No problem. Five something.
1, 2, 3, 4. 4 partial repository and 2 is okay. No, 6 is there, but I have not put it here. Okay. Two dot 06. 1419 1424. Okay.
Okay.
So name, you want to proceed with alpha, or else you want to change it. So now,
Sure. Mhm.
after this, in the end, start listener lsn dot or queue manager name dot lsn, whatever the name I have given there. Okay, lsn dot queue manager 01. Start lsn dot queue manager 02. You have to go to each and every queue manager and start it. Once you start, okay,
Okay.
you have to define the object. Define queue local LQ in the brackets cluster of ALPHL. Now this particular queue you can put message
Okay.
from anywhere.
Okay.
For example, if you are defining this queue in QMGR 01,
Mhm. Mhm.
okay, if it is at
Okay.
cluster level,
Okay.
you can put message from anywhere. But if you are creating at only one queue manager, from this particular queue manager only you can get the messages. But put action, you can do it from anywhere.
Anywhere. Okay. Okay.
But if you create the same queue in all the queue managers,
Mhm.
if you put 10 messages, sorry, if you put
Okay.
12 messages, there is some
Mhm.
workload balancing will happen. That
Okay.
for that little bit more modifications has to do. Those are the commands
Okay.
below. But first we'll see cluster setup here. Till
Okay.
this, if you do, if all the
Okay.
channels are up and running fine, if you are able to put from any queue manager,
Okay.
if you create a queue, QMGR0, if you create a queue in
Mm-hmm.
QMGR01, okay,
Mm-hmm. Okay.
and try to access it from QMGR AMQS puts, okay, then the remote queue name will be, no, there's no remote queue, so QMGR 01 dot LQ, you try it from QMGR 03 or
Mm.
QMGR 04 or QMGR 02 or except QMGR 01.
Okay. Okay.
2, 3, 4, 5. What is this? This program is a free software. You can modify it under GNU Public. You should receive a copy of GNU Public. What is this? What I have to do?
Click on OK.
Yeah,
That's it.
I clicked on OK, but it is not going.
We just keep opening, is it?
Huh?
We just keep opening again and again.
Yeah.
Oh,
Okay. How about now? If I close this, all my notepads will get closed or what?
no, no, no.
Because I have a huge
It will be
data
there.
here now.
It will be there. Mm.
I can't lose it. Okay.
Maybe you reached a maximum tab size or what?
Might be. Any doubts so far?
Till now, all clear.
We can't do lab today. Okay. Or
Yeah,
you
yeah.
want to
Okay,
do
no
it today
problem.
only if you are available.
No problem. No problem. Tomorrow you can do.
I am working from home today, so I am available.
Okay.
If you are available, let me know.
No, I'm going to do.
Okay, then we'll connect tomorrow. I'll give you these steps.
Sure, sure. So tomorrow 5:30, yeah, then I will sleep some extra time then. If it is 5, then I will join 5.
Okay. Uh, okay, you call me, okay?
Okay,
I'll
okay,
finish my walking bit early and then join you back.
okay, sure. Right, actually here the WhatsApp calls are banned actually. So whenever I call, I connect a VPN and call.
Oh, okay.
Yeah. So I will give you missed call. Missed call will work in WhatsApp. I will call from. Okay.
Oh, this is also 2 minute extra. So you got CRTMQ and define listener. That's it, right? Hmm. 1, 2, 3. Okay, done. 4, 5, 6. Can you share your screen now? So if the alignment of this creation of cluster is good, then you're good to go.
Okay, okay.
Because the rest of the things are just a simply copy-paste execution. We need to have a clear concept. Once this channel started running, then we are awesome.
Okay.
Okay.
Yeah, sure.
Yeah. See you tomorrow.
Okay, okay. Thank you.
Yeah.
Bye.
Thank you. Bye.